Okay. I'll be surprised if we get done with this one. There'll probably be a next one. But okay, we got an object is thrown from the origin of coordinate system with the x-axis along the ground and the y-axis around the vertical. So that's normal. Its path or trajectory is given by this equation. Find the object's max height. Well, it's the same type question as what we did before. It's just different numbers. So before we had 224t minus 16t squared. Now we've got 280x minus 16x squared. Same basic thing. Now I will solve this a different way. So this is just an optional way to solve it in case you don't want to do the negative b over 2a, just throwing it out there, because what they're saying is you've got a parabola, because it isn't that negative 16x squared plus 280x, so it's going down, so it's doing that. It wants to know the max height, so basically we just, come on, right thing, we need to know the y part of the vertex, so whatever the vertex is, we need the y part. Now, it's thrown here, so if we know those, the vertex is going to be dead center. So quite honestly, you could take this thing and you could, this, again, optional way of doing it, factor it out. So negative 16x, take that out of 280. So let's see here, 280 divided by 16. Okay, but that's 17.5. So instead of doing that, let's just do, what's 280 divided by 8? Okay, that's better. Okay, so 8x, so that's going to be 35, and that would be minus 2x. So all I did was take that right there and I factored it. Well, if I set both equal to 0 because I want to know what my x-intercepts are, then this one gives me 8x equals 0. So x is 0, which is what I anticipated because that's where it started. Now this one is the one I'm really interested in. 35 minus 2x equals 0. So 35 equals 2x. X is 35 over 2 or 17.5. Now, that ain't the answer. That's the time it takes to get here. Here, let's do a different color. So this is 17.5. I want to know the y part that goes with 17.5. So all you do is plug 17.5 back in there. So I guess it's just a different way of finding the x. I don't know if that helps you. It may or may not. Hope I didn't confuse you. So 280 times 17.5 minus 16 times, oh Lord, I ran out of room, 17.5 squared. You can just type that in your calculator. 280 and then times 17.5, close it off, minus 16 and then 17.5 squared. Why did I do that? Excuse me. I so messed up. My bad. Ah. My eraser is so small, it won't erase. Okay. So sorry. I presumed. That's not where the 17.5 goes, is it? 17.5, this is what you get when you go in a hurry. You make bad mistakes. So 17.5 was the other mark right here, 17.5. We want half of that. So 17.5 divided by 2 is 8.75. My bad. Okay, so now you take 8.75 and stick it in there. I knew something was wrong because my calculator told me 0 when I plugged it in, which, I mean, that's how I found it. So let's see here. Y equals 280 times 8.75 minus 16 times 8.75 squared. So it's just a matter of typing it in. So 280 times 8.75 minus 16, and then I got 8.75, close it up, squared. That would be 1225. So sorry about the boo-boo, but you know, that's just the way it goes sometimes. Okay, so number 53, we've got a polynomial. Use synthetic division to find the value when p, when it's evaluated at 10, put it that way. You could do remainder theorem as well, right? Because this is set up like remainder theorem, or you could just do synthetic division like they said. You've got the sign you want. 10 is fine. Make sure you don't have any skips or jumps. We don't. We've got third, second, first number, so there's no powers that are missing. And make sure you put your signs down here with your number. Underneath the last one is the remainder, so we're going to drop, multiply, add, multiply. Oh, Lord, we're getting out of hand now. So that's going to be 543, and so that would be 5,430, instead of 5,439. Wow, that's big. And that's right. So that's exactly it. So, because remember, this is remainder theorem, so it's wanting to know, that's the notation for remainder theorem, so it's wanting to know what the remainder theorem, the remainder is. Okay, so a partial set is given for this equation. Find the complete solution set. So remember, they're telling you to do synthetic division with that one. And there are no skips or jumps, so we got 1, 9, 14, and negative 24. I wouldn't worry about doing P over Q and Descartes' rule of signs because this is a cube. And once you run this one solution through, you're going to have a quadratic, and you can either solve it by factoring, square root, property, or you can do quadratic formula. Either one of those are going to work, and you don't really need the other. So we multiply, we add, we multiply, we add, and then we multiply. We were expecting that because they told us it was a solution. If you didn't get a 0, you needed to go back and find your boo-boo. Since that was x to the third, this would be x squared. And then factor. What two numbers multiply to 6, but yet subtract to 5? Now make sure you get that through your head. That's subtract to 5, not add to 5. So it's got to be 6 to 1, or 6 and 1. Signs are different, big one's plus. So solve them out. We need a negative 6 and we need a 1. So if you really wanted to get all meticulous about it, your whole list would be negative 4, negative 6, and 1. Some way, somehow. You got to have them all. Okay, so find all the rational zeros of the polynomial. This is where you need your P over Q. Now, quite honestly, I'm going to jump straight into the P over Q because the Q is 1. So there's no need to make it last longer than it really is. So I just need all the numbers that go into 16. And that's pretty much all there is. Let's see if Descartes got anything to tell us. All right, if you do the signs as is, aha, he is screaming from the grave. There are no changes, so don't waste your time looking at positive options. So he just took our pool of answers and our pool of solutions and cut them in half. If it's an odd power, you change it. Even power stays. Odd changes, even stays. So we change 1, 2, 3. So this is going to be 3 or 1 negative real root. All right, so let's start trying some negative numbers. We've got 1, we've got 6, we've got 12, we've got 16. So if we're going to try some negative numbers, I'm just saying let's just do negative 1. I haven't worked it, so I don't know. So that's going to be a negative 1. That'd be 5. Multiplies negative 5. That would be, what is that? Oh, 7. That is not going to work. So let's do negative 2. All right, so negative 2 times that would go here. And that would give me 4. Well, that'd be a negative 8. That would be 4. That didn't work either. So let's go to negative 4. So I go through negative 4. That's going to be a 2. Negative 4 times 2 is negative 8. Which, I mean, that's actually going to work right now because now I got my 4. So negative 4 times 4 is negative 16. Eureka, I finally found one. So we've got x squared plus 2x plus 4 equals 0. And you can't factor that. So you're either going to have to complete the square or do the quadratic formula. I'm not going to complete the square because I know that would annoy some of you, even though it's faster than quadratic formula. So you can dive straight into the quadratic formula. I assume y'all know what it is. The opposite of b plus or minus b squared, which would be 4, minus 4 times the a value times the c value, all over 2 times the a value. So that means I have 4 minus, now always do this part first. There's only one negative, so that's going to be minus 16. That's the reason you couldn't factor it, is because that's going to be, that's going to be square root of a negative 12. All right, so you got to break that down. Remember, there's a 4 hiding in there. So the square root of the 4 comes out as a 2, and we got to put an I because it's negative. So make sure you have all your components. You can reduce because all of these are the same. Remember, it has to be all 3 or nothing. Divide them all by 2. Now, you are mandated to have a value here. If the other 2 go to 1, it's okay. You can leave the ones out, but you have to have a 1 in the first spot. So negative 1 plus or minus I square root of 3. So your zeros or roots or whatever you want to call them, solutions, you had negative 4 worked, and then we had negative 1 plus or minus I square root of 3. And that should sum it up. Okay, so if we keep going, Find all the real zeros of this polynomial. Use quadratic formula if necessary. So, okay. Again, your Q value is 1, so let's not waste our time listing out a bunch of stuff that we don't have to. So it's just all the factors of 4. The good thing is we got a small list. Now let's see if Descartes tells us anything. We have plus, 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 minus. Okay, so he's saying there's possibly one positive real root. All right, so odd power changes, even power same, odd power changes, even power same. So change, change. It could be 2 or it could be 0 negative real roots. Well, let's just get started. I know that there's a positive one. Now, whether or not it's rational is a different story. It might be a square root. It might be square root of 2. It's real. It's just not going to be rational in this list up here. So let's see here. What to try? I guess we could just try the 2. I don't know. And let's see here. 2 times 1 is 2, so that's going to give me 10. That would be 20. Oh, this is blowing up. That's an upper bound. It's not going to be 2. So positive 2 is out, and I wouldn't try positive 4 either. That's just getting too big. Okay. Anytime it starts blowing up like that, that's an upper bound. Okay, so put your 1. 1 times 1 is 1. That's going to be 9. 1 times 9 is 9. I mean, it's still blowing up, isn't it? Okay, so I bet that positive real root is going to be a crazy radical. So let's see if negative works. So that's going to be a negative 1. Well, that takes me down to a 7. That'll be a negative 7. And that makes what? 3. So it'd be a negative 3, and that didn't work either. So what about negative 2? So that would be negative 2. That'd be 6. That'd be a negative 12. Well, that'd be a negative 2. Negative 2, negative 2. Oh, that's positive 4. Praise the Lord, we've got one. Okay, so negative 2 worked. So I'm left with x squared plus 6x minus 2 equals 0. Quadratic formula, here we come. So x equals the opposite of b plus or minus the square root of b squared minus 4, and then a is 1 and c is a negative 2. All right, so 2 times a, which is 1. All right, so whenever I come in here and I'm doing this back end, notice there's 2 negatives, so that's going to make a positive. So I'm just going to add those up. Okay, so that's going to give me negative 6 plus or minus, that's the square root of, oh, let's see here, 44 over 2. I can take a 4 out of that. So square root of 4 is 2, and that's 11, because 4 times 11 gives me 44. But once again, you can reduce. And you reduce all 3 of these by the same value, so everything divided by 2. So that leaves me square root of 11. So I've got negative 2, and then I've got negative 3 plus or minus square root 11. Those are all my zeros. All right, let's see what's coming up next. Tell you what, since this is swapping ideas, let's go ahead and stop this video, and then we'll start over with problem 57 on the next one.